Hey guys, Drew up here, and welcome to the third episode in our Let's Learn Java series. And in this episode, we're going to be learning how to store data as variables. Right, so we've been doing all these math operations. I've even told you about variables that exist, such as strings, integers, doubles, floats. How do we actually make them? Right, because we're doing all this math, we want to keep this math around, right? So storing variables is very simple, very easy. So what we do is we type in what type of variable we want, right? Int is an integer, this type of variable, and then we give it a name, right? What do we want to name it? I want to name it number, right? And that's it. That's all you really need to do. So it is always recommended to initialize your variables. So I'm going to set this equal to 0. Okay. So now I have this integer that's called number. My system at out print line, we're gonna print out my number, right? So I can just straight up give it the variable name. I'm gonna save it. Oh, where did my always do this? There it is. All right, so I'm gonna compile, run. Hey, 0, right? It doesn't print out the word number. It prints out 0 because that's what our number is stored as. Handy dandy. So now we can do operations to this number. So I'm gonna say this is 5. Remember how we did that before? So I'm gonna say number is equal to, so I'm going to set it equal to number times 5. Right? Now remember, our number is synonymous with 5. We're just going to take number 5 times 5. And then it's going to take the results of 5 times 5, and it's going to store it back into our number variable, and then we're going to print out number. This should give us 25. File and run. We get 25. Look at that. Handy dandy. And we can do that for all of our operations we saw before, where we plus, minus, all that. But there's a couple little key tricks here when it comes to this. So not only can we say number equals numbers times 5, but that's a lot of typing, okay? And programmers, you do a lot of typing as a programmer, and we try to cut down on typing as much as possible. So you don't have to say numbers again. You can say multiplies equals. Now what this will do is it'll do exactly what our previous code did, but you don't have to type number again. Same thing with, get rid of those. Same thing with plus equals, minus equals, divide equals. All do the same thing. You don't have to type number again. It'll automatically do that. So 5 divided by 5 will give us 1, right? So if we compile this, run, hey look, we get 1. Perfect, right? That's what you want. So we can still do our math operations. Let's talk about the different types of data types. So I just showed you an integer, right? What if we want to have a decimal number, right? So we had a double, in all caps, double, right? This is our big number, right? So it was like number with decimal. That's me. Amazing name, number with decimal. So that's our 5.0, okay? So that was our 64-bit number. But what about our float? You know, our small one. Well, guess what? It's called a float. Number with less decimal. These are really big names. Do not name your variables these big names. You will hate yourself for having to type all this out. But we store that as a 5F, remember? We had 5.0, 5.0, and 5F. Those are our two. Now, our integer is 32 bits. And our float is 32 bits, and our double is 64 bits. Isn't there a 64-bit integer? Well, I'm glad you asked. There is. I'm going to put it right here. It's called a long, because it's a big number. Right? Equals... Now, actually, you see how these have special, like, 0 and F? There is actually a long denoter. You put an L, a capital L, after the number, and that denotes it as a long variable. Otherwise, it treats it as an integer. And if your number is really big, then it'll actually throw an error if you don't have the L. It's a pretty big number there, but that should be able to store. Okay, so once again, we can print these out. We can do number plus big number, which will give us a long result because one of our math guys is a boom, and we get a really big number, right? Works the same as you'd expect. So we got int, long, double, and float. Now, you know, we have string, right? So how do we do a string? So string is text. I'm gonna call it text, and we set it equal to hey, right? So there's our text. Type in text here. Give it a nice little save. Give you a second to make sure you copy that down. You're good. You got it. All right. Let's compile. Oh, compile. Compile. Up. Semicolon. Semicolons are important. I think I forgot to mention that in the first video. Semicolons. After everything, semicolon. Semicolon is very important. It'll complain if you don't. Now, some things don't require a semicolon, like here. Don't do a semicolon there. That won't work. Semicolon after every command. Yes. Almost forgot. That is really important. Hopefully you figured that out just by watching me. So compile that. We'll run it. Hey, it says hey. Right, oop, jeez. Just like we wanted. We wanted to say hey, right? We took hey, stored it as text, and then we printed out text. Works, right? What if we did? Can we do math with text? Well, we can, but not really math. It's called string concatenation, where you add two strings together. So I've said text plus more text, right? This isn't actually going to do math, but it's going to take hey and more text and add them together into one string. And then we're going to compile it, give it a run. Hey, more text. Works just like that. All right. So we got text. Text are actually a class. Now you notice the difference here. Int, lowercase, long, all lowercase, double, all lowercase, float, all lowercase, string. That's a capital letter right there. What is going on? What is going on there? Well, the thing is class objects, you always capitalize. You see how our tutorial is capitalized? That's because string is actually a class. It's not a primitive. These are all called primitives. It's not actually a primitive, but it's a default class in Java that everything extends. So you can use it. But actually, what it is made up of is called chars, which are, I'm going to call it a character. And that is single, like apostrophes, make it car. A char. That can only store one character. It can't store text like a text can. Right? So I say C. Oh, where am I going here? Here we go, compile. Oh, it's not C, it's a character. There's a difference there. And then I'm gonna, oh geez, no. Don't tell me I just opened up Premiere. Anyways, so we run it, we get the letter C. So the way a string, this is gonna be really, manager, process. What, where's that? Premiere, Adobe, Premiere, get out of here. Don't you dare start. So a string is a bunch of characters put next to each other. So you got an H, an E, and a Y. You can do the same thing. So basically what's inside of a string would be like H plus E plus Y. Right? I'm oversimplifying this, but this is to give you an idea. This is what a string is basically doing. So you get hey. Oh, okay. This brings me into point 2 here about characters. Okay, it didn't do exactly what I wanted it to do. You can't exactly add those together because a character is actually a number, right? It's a Unicode number. You know how like each character has like a number to it? Well, that's what character stores. Character stores those Unicode numbers. So it stores the Unicode for a C. I can also say like 64. And if I remember right, 64 is a lowercase a. Right, let's print that out. Hopefully it doesn't just print out, I'm losing myself here. Hopefully it doesn't just print out 64. Oh, it's an @ symbol. That was wrong. So it's an @ symbol, but you get the point. It's a number. And the reason it prints out the character instead of the number 64 is because I'm passing it as a character, and print line recognizes, hey, this is a character, treat it like a character. Right? But so all these have different memory sizes. We still haven't even gone through all the things yet. I'm going to get through them all, and then I'm going to discuss the memory sizes. The next thing we have is a boolean, and a boolean is true and false, right? True, false, right? I'm gonna name it like that. Also, notice how I name things. Lowercase first letter, capital, any following words, number with less decimal. That is the standard. It's called Camel Case. Everybody does it. Well, at least most people do it, and you should do it too. And what a boolean stores is either 1 or 0, and that's literally everything it can store. Now, because 1 and 0 are very common in code, Java recognizes false as 0 and true as 1. So you can say this is true, which will store it as 1. And you can print this out. Print out true, false. And we're going to get true, false. Compile, run, and it tells us true. It doesn't say 1 or 0, but it'll actually tell us true or false. Okay, and this is actually very important and will be greatly explained in the next episode when I start talking about control statements. Booleans and whether something's true or false is like 80% of programming, so that's important. We're going to cover that. And then other types, you got char, you got a short, which is short and a character, basically the same thing. Just to know it's a small number. I'll tell you why it's a small number in a second. And then byte. Byte is even smaller number. 2. It's just a not that small, but it's small. You know, like byte goes up to 16. Or is it 8 bits? If it's 8 bits, I think it's 128 is the for small. So we'll go for 64. 64. All right, and I think that's everything. That's a primitive. All right, now let's discuss what these are in memory. So integer, an int is 32 bits. Okay, or 4 bytes. You're one of those people. A long, 64 bits, 8 bytes. A double, once again, is 64 bits, 8 byte. Now, because of how floating point numbers work, it's divided in half, so it's 32 bits for the integer part. So like, there's 32 bits to store the left side, and there's 32 bits for the right side. That makes sense, okay? Same thing with the float, but the float, 32 bits, 4 bytes. So there is 2 bytes for the left side and 2 bytes for the right side. That's why they store a lot less memory. So we got string, which has no default size. It's made up of a bunch of characters, and its size depends on how many characters you put inside of it. A character is 2 bytes, or 16 bits. If I can type, I got a band-aid on my finger. 16 bits, 2 bytes. Boolean is 1 bit. It's very handy. It's 0 or 1, that's all it is. And then we got a short, small number, which actually is 1 bit, but I think it's actually stored in memory as 1 byte. It could be wrong here, but it only takes up 1 bit of space, but because memory works better when it's padded, and it makes sense because it wouldn't make sense to just use 1 bit. I'm pretty sure it actually takes up 1 byte of memory when you actually store it. But I think it's only one. It should be only like 1 bit or 1 byte. I'm not entirely sure. Short is 2 bits, 2 bytes. And 16 bits, 2 bytes. Oh, you notice the similarity here between the short and the char. Pick up the same amount of memory. They store the same amount of number data. Crazy. Well, yeah, they are basically the same thing. It's just that character is instinctively thought of as Unicode. You're giving it Unicode, whereas short it's a number. There's nothing character related about it. That's the only difference. And then you got a byte, which you want to take a shot in the dark how big this one is. 8 bits or 1 byte. Which all this is handy dandy information. So if you want a really big number, you want to use your longs and your doubles. Or most of the time, you're just going to use integer because you usually don't go over an integer size. Pretty rare occasions you'll use a long. Usually just use a double. Now there is actually a speed difference. Your computer processes floats faster than it processes doubles, but the difference is so small that it doesn't matter. So you can just use doubles over floats. And yeah, and that's all of the primitive data types and declaring variables that I can think of. Right? Also, just note, so like, you know how I have it storing it as a number? You can say, instead of that, I can put number here. So big number is equal to number. So they'll take 5. Remember, this is 5. So big number is stored as 5. It's things like that that make it simple. It's trying to store a double into a float. It'll yell at you if you do that. So in order to do that, you have to do what's called casting. So like, let's do an example of that real quick, just because it's on topic. So float number A equals 5.0 and double number B equals number A. It should complain. I want to print out number B. Oh geez, get rid of my parentheses. I need those parentheses. That's semicolon. We'll save that off. Compile. Not complain there. And it did 5.0. It might be the other way around. Going from double to float is a loss of data. And it might just be something that Notepad is not capable of complaining about to you. But we'll see if it complains. It did complain. There we go. Told you it complained. So going from a big double to a small float, you have it's a lossly conversion, meaning you're gonna lose information, and it'll complain, and it won't actually compile. In order to do this, you have to convert it, and to convert it, you gotta put in parentheses float. So this is going to take number A, which is a double, convert it to a float. I swear, keep making more noises. Anyways, convert number A to a float and store it into number B, which is a float, and by doing that, it'll accept it. So if you compile it, no more error, you run it, you get your number. That is it for today. I hope you guys enjoyed this video. It's been kind of long, but hopefully it's been informative. So comment, rate, subscribe, and thanks for watching.